Hello everyone, today's going to be kind of a review day and we're going to go back and just kind of look at some mixed factoring, and we have to choose which method we're going to use to factor. So whenever we're factoring, we're always going to look for the greatest common factor first, okay? Because if our polynomial has a greatest common factor, we want to pull that thing out and make the rest of our job easier in factoring this thing, okay? After I pull that greatest common factor out, okay, I may not be able to go any further, but if I have 2, 3, or 4 terms, I'm going to try to use one of these methods to factor more. So if there are 2 terms, we're going to look to see if it is a difference of squares. And if it is a difference of squares, it's going to break apart like we saw in the previous lesson, okay? If it's not a difference of squares, we're going to have to leave it alone because it cannot break apart any further. Okay, if we have 3 terms, okay, we're either going to have a leading coefficient of 1, where we factored by finding factors of this number that add to make this number, so negative 10 and negative 2, add to make negative 12, and they multiply to make 20. Okay, so that's all we had to do if there's not a number in front. If there is a number in front, then we had to break it apart by grouping. Okay, and you can see that process there. Our factors are going to look like this in the end. Okay, so that's 2 types of problems we'll see. Also, if I have 4 terms, I'm going to factor by grouping. Okay, so I'm going to break this thing into 2 groups, these 2 terms and these 2 terms, and then factor as you see there. Okay, another thing to notice, if I can break this apart more, I need to do it. Okay, this cannot be broken apart, but if this happened to be a difference of squares, then our job would not be over. We'd have to keep going and factor a little bit more. All right, so the first example, first thing we want to do is look for a common factor, and these do have a common factor. I can divide both of these things by 2. So we're going to pull that out, 2 and x to the 4th minus 81. So now that I have 2 terms, I'm going to look to see if this is a difference of squares. And yes, it is. Okay, x to the 4th can be broken apart as x squared and x squared. 81 can be broken apart as 9 and 9. One of those 9s must be negative. Okay, so that's going to become x squared minus 9, x squared plus 9. Okay, don't forget this 2. Let's go ahead and bring that down. Okay, now I still have 2 terms here, so I'm still going to look at this thing and see, is this still a difference of squares? And yes, it is. Okay, so this one actually breaks apart as x times x. That breaks apart as 3 times 3. One of those 3's is negative. This is not a difference of squares because we're adding. Okay, so that's going to have to stay. I cannot break that down. So here are our factors in the end. 2 times x minus 3 times x plus 3, okay, and then bring the x squared plus 9 down. So there are the factors of this thing. Okay, here's another one. Okay, again, the first step, look for a common factor. This first term doesn't have a number, and this last term does not have an x. So there's nothing common between all 4 terms. So since we have 4 terms, we're going to factor by grouping. So break this into 2 groups. These first 2 terms, they both have x squared, and then we're left with x plus 3. The second 2 terms, you're going to bring down that negative 16, or the negative, and they can both be divided by 16, okay? And then we're left with x plus 3. Okay, so now there is a common factor between these 2 groups, x plus 3. So we bring that down, x plus 3, and then x squared plus or minus 16. That's what's left over here. So there are our factors, but since we have 2 terms, make sure that you do not have a difference of squares. This second one is a difference of squares. It can be broken apart as x times x and 4 times 4, and one of those 4's must be negative. So here are the factors of this thing, x plus 3, x minus 4 and x plus 4.
This is a 1-minute warning bell.
So that's it for that one. Okay. Sometimes we're going to see higher power trinomials, okay, and they're really going to factor just like we would with a regular trinomial. And let's take a look at these. All these are pretty similar. This first one, what I would do is I would look for factors of negative 12 that add to make a positive 1. So 1 and 12, 2 and 6, 3 and 4. Negative 3 and 4 make that positive 1 for me. So I have x minus 3 and x plus 4. Okay. Now, notice this next one is x to the 4th power. Okay. So this x to the 4th power is actually just going to break apart as x squared and x squared. Your factors are really going to be the same. So our factors are going to be x squared minus 3 and x squared plus 4. Okay. The next one, since I have x to the 6th power, that's actually going to break apart as x cubed and x cubed. So our factors would be x cubed minus 3 and x cubed plus 4. Okay. And this next one is just going to be x to the 4th minus 3 and x to the 4th plus 4. And then the last one would be x to the 5th minus 3 and x to the 5th plus 4. Okay, so something that we must notice here is that this middle term, the degree is always half of this one. And you notice that 2 is half of 4, 3 is half of 6, 4 is half of 8. Okay, so this is always going to work. I'm always going to be able to find factors of that last number that add to make the middle if you see something like that. And they're going to break apart like this. Okay, so here's another example. So first thing, is there a common factor? There's not. Okay, so we notice that this follows the pattern. We have 6th power, 3rd power, and then no exponent. So this is half of that. So we can factor this thing by finding factors of negative 100 that add to make negative 21. So I've got 1 and 100, 2 and 50, 4 and 25, 5 and 20, and then 10 and 10. So those are my factors. Okay, so I can make a negative 21 with 4 minus 25. So those are the factors that I want to use. So my factors are just going to be x cubed plus 4 and x cubed minus 25. Okay, I cannot break this one apart more because this is not a difference of squares. X cubed cannot be broken apart as two factors that are the same. So if it was x to the 4th power, I could break this thing apart more, but that's as far as this thing can go. So this is our answer right here. Okay. All right, here's another example. So again, it kind of follows a similar pattern. We have x to the 4th power, x squared. So first thing, there is not a common factor, okay? But our leading coefficient is negative. So let's go ahead and pull that negative out of this thing. So we have a negative, and then we have 3x to the 4th minus 7x squared minus 20. So now, to factor this thing, we're going to multiply 3 and negative 20 together. That's negative 60, okay? And find factors of negative 60 that add to make negative 7. So, and there's all of our factors, okay? And I can make negative 7 with 5 minus 12, Okay, so let's factor this thing by grouping. So let's rewrite it as 3x to the fourth plus 5x squared minus 12x squared minus 20. We're going to break it into two groups. This first group, it has x squared in common, and that's going to leave me with 3x squared plus 5. The second group, it has a negative, and then we're going to divide. Both of these things can be divided by 4. So that's going to leave us with 3x squared plus 5. Okay, so the common factor between these groups is 3x squared plus 5. Okay, bring down this negative from before, and then x squared minus 4 will come down. And then x squared minus 4 is actually a difference of squares. So that's going to break apart as this. So we end up with negative 3x squared plus 5 times x minus 2 and x plus 2. And that's completely factored. Okay, one more example. So we have 4 terms. First thing to check, is there a common factor? And there's not. There's nothing that, actually back up, there is a common factor. I can divide all of these things by 2. So we're going to pull this 2 out, and then we're left with 2x cubed plus 5x squared minus 18x minus 45. Okay, so now since we have 4 terms, let's factor by grouping. Okay, so this first group, they both have x squared, and that leaves us with 2x plus 5. The second group, pull off the negative. They can both be divided by 9, and that leaves us with 2x plus 5. Okay, so our common factor is 2x plus 5. And then we're leftovers is x squared minus 9. Okay, I'm actually not done here because x squared minus 9 is also a difference of squares. So that breaks apart as x times x. That breaks apart as 3 times 3. One of those has to be negative. So our factors are 2x plus 5, and then we have x minus 3 and x plus 3. And that's it. Okay, so this is actually the last lesson of this unit, but you guys should be able to take what we've learned and apply it to any problem that you come across. So please go check out the assignment on Canvas, and let me know if you have any questions. Have a great day.